In this video, we're going to talk about the Pythagorean Theorem. The Pythagorean Theorem is used to find missing side lengths of a right triangle. The formula is a squared plus b squared equals c squared. And here's what a, b, and c stand for. A stands for the length of a leg. So the vertical and the horizontal part of the right triangle, those are called legs. So A and B are interchangeable. This could be A or B, this could be A or B, it does not matter. But they are both referred to as legs of the right triangle. C is called the hypotenuse. The hypotenuse is always the longest side. It is the diagonal side. Okay, so the legs go up and down, right and left, or vertical and horizontal. Then the hypotenuse is the diagonal part of the right triangle. The hypotenuse will always be across from the right angle, okay? Or across from the 90-degree angle. Another term we're going to talk about is called a Pythagorean triple. A Pythagorean triple is a set of positive integers, a, b, and c, that fit the rule a squared plus b squared equals c squared. So a couple examples, 3, 4, 5. So this would be 3, 4, 5, 5, 12, 13, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Those are probably the most common Pythagorean triples, and off of these we can have multiples that are also Pythagorean triples. So a Pythagorean triple here could be 6, 8, 10 if you multiply them by 2, or 30, 40, 50 if we multiply them all by 10. So remember, the biggest number is always the hypotenuse. So that'll kind of help you know where to label those. And the other two numbers are called the legs, and those can go either on the vertical leg or the horizontal leg. It does not matter. Okay, so we're going to look at some practice problems here with Pythagorean theorem and do a little bit of work with it. Okay, so we'll zoom in here a little bit. All right, looking on the left side of the paper first, we'll look at numbers 1 and 2 up here. And then we'll look at 5, 6, and 8, and then we'll do 10 through 15 on the right, and there are 3 additional problems here at the bottom, okay? All right, so looking at number 1. I know it's kind of hard to see because it's kind of small, but number 1 says, for each triangle, find the missing length. We're going to round our answer to the nearest tenth, and then we're going to find the area and the perimeter. Right now, we're not going to find the area and the perimeter. We're just going to determine the missing length of our right triangle. Okay, so number 1, we have a right triangle here. They've given us the hypotenuse and they've given us a leg, and they want us to find the other leg. So the numbers they've given us, I know they're kind of small. The hypotenuse is 19 and one leg is 17. So what we're going to do is we're going to take our formula on number 1. We're going to say a squared plus b squared equals c squared. And we can fill in our numbers that they've given us. So 19 is c squared, and we can say that 17 is a squared or b squared. It does not matter. Okay, so we'll just say it's b for right now. So we'll say a squared plus 17 squared equals 19 squared. So now we can simplify a little bit. A squared stays a squared, 17 squared is 289, and 19 squared is 361. So at this point, we're trying to solve for a. So we subtract 289 from both sides. That cancels out, and we get a squared equals 361 minus 289, and that gives us 72. So now we're trying to find the inverse of squaring a number, which would be to take the square root. So we do that to both sides, and we take the square root of 72, and we get approximately 8.5 when we round to the nearest tenth, okay? All right, so number 2. Number 2 is a little bit different because they've given us 2 legs and not the hypotenuse. So for number 2, we're going to say a squared plus b squared equals c squared. And now we have a and b, we don't have c. So now we have 5 squared plus 13 squared equals c squared. 5 squared is 25. 13 squared is 169, and that is equal to c squared. So now on the left side, we have like terms that we can add together. 25 plus 169 gets us 194, and that's equal to c squared. Once again, just like up here, we're going to take the square root of both sides, and we get the square root of 194 as approximately 13.9. And we have found the missing legs, or the missing sides, the leg on number 1 and the hypotenuse on number 2. Okay. On 5, 6, and 8, we're going to do sort of the same thing here, but they didn't give us a triangle. They're just giving us A and B, or A and C, or B and C, and we're trying to find the missing length. Okay. So on number 5, they tell us that A is 12 and B is 5. So now we have 12 squared plus 5 squared equals C squared. Well, 12 squared is 144, 5 squared is 25, and that equals C squared. So we add those together, 144 plus 25, and we get 169 equals C squared. Take the square root of both sides, and that is a perfect square. So C is equal to 13. So if we look here, this would be a Pythagorean triple, 5, 12, 13, because there are no decimals here. Notice we had a decimal on number 1 and number 2. So those are not Pythagorean triples because they don't come out to whole numbers. All right. On number 6, we have A is 8, B is unknown, and C is 10. So we take our numbers they've given us and we say 8 squared plus B squared, because we don't know it, equals 10 squared. 8 squared is 64 plus B squared equals 10 squared is 100. All right, so now we have to subtract 64 from both sides. That cancels out, and we get B squared equals 36. Take the square root of both sides, and we get B equals 6, because that is a perfect square. The square root of 36 is 6. So once again, we have a 6, 8, 10 Pythagorean triple. All right, number 8. We're missing A now, so we're going to have, we'll do number 8 right here. Okay, so number 8, we have A squared plus B squared equals C squared. They have not given us A. B is 40 squared, and that equals 50 squared. So now we say A squared plus 1600, which would be 40 squared, equals 2500, which would be 50 squared. So now we subtract 1600 from both sides, and we get A squared equals 900, square root of both sides, and that would give us 30. So we have our Pythagorean triple again of 30, 40, and 50. See the work there, okay? All right, now we're gonna go up here to number 10, and we'll look at 10 through 15 on the right side. Number 10 says, find a third number so that the 3 numbers form a right triangle. Okay, so on part I here, or the first part of 10, they've given us 9 and 41. Well, we've said that the biggest number has to be the hypotenuse. So let's start off with saying that 9 is A. So we'll say 9 squared plus B squared equals 41 squared. All right, we're going to use 41 as the hypotenuse. And what we're going to do is we're going to take our calculator and we're going to plug in, or basically we're going to solve this and see what B would come out to, okay? So we know 9 squared is 81 plus B squared. Might not have 41 squared memorized, so we type that in our calculator and we get 1,681. So now we're going to subtract 81 from both sides. And right here, those will cancel and we'll get B squared equals 1,600, which is going to work out perfectly because when we take the square root, that's like taking the square root of 16, but adding a 0 to the end. Okay, so we're going to get the square root of, so second square root, 1,600, and we end up with 40. So we would say that our third number, or B, is 40. So we're just plugging in the 2 numbers they gave us to find the missing side length. Let's do the same thing here. We'll say 13 squared plus B squared equals 85 squared. 13 squared, we have that one memorized, that's 169. Plus B squared equals 85 squared is 7,225. Just like up here, we got to move 169 over there by subtracting it. So we're going to take 7,225 minus 169, and we get B squared equals 7,056. Take the square root of both sides. Let me show you a trick on the calculator here. Down here is our negative sign. In blue it says ANS. So ANS means that means answer. So let me pull that up for you a little bit so that we can see it. So right here, ANS, that means answer. So when I hit second, that's gonna take me, or second answer, that takes me back to the previous answer that was on, or the answer that was on the previous screen. So right now we have 7,056. So if I say second square root second answer, that's gonna take the square root of the answer I just had, which was 7,056. I hit enter and I get B equals 84. Okay, so I found the missing side length. All right, on 11 through 15 is kind of some word problems here. And we're gonna have to apply the Pythagorean theorem to this. It says, Mrs. Green tells you that a right triangle has a hypotenuse of 13. So let's draw a right triangle here. Doesn't matter which way it faces. The hypotenuse is 13 and a leg of 5. She asks you to find the other leg of the triangle. What is your answer? So we're gonna plug in. We know that this is C, 5 could be A or B. So let's say 5 squared plus B squared equals 13 squared. 5 squared is 25. 13 squared is 169. We would subtract 25 to bring it over here. 169 minus 25 gives us 144. And we say B squared is 144. Square root of both sides. Square root of 144 is 12. So B is 12 there. Number 12, 2 joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So we're gonna draw us a little picture here. 8 miles north, we can say that's up on our paper. And then 5 miles west. So we'll go to the left on our paper. So we'll label that 8, we'll label that 5. And what they're asking us, what is the shortest distance they must travel to return to their starting point? Well, we know the shortest distance between 2 points is a straight line. So we're trying to find the hypotenuse of this triangle. So we would say 8 squared plus 5 squared equals C squared. So 8 squared is 64, 5 squared is 25, and that's equal to C squared. We add 64 plus 25 and we get 89. So C squared is equal to 89. We can take the square root, so remember second square root, second answer. And we get approximately 9.4 miles. So we would say 9.4 miles would be our answer. Number 13, Oscar's dog house is shaped like a tent. The slanted sides are both 5 feet long and the bottom of the house is 6 feet across. What is the height of his dog house in feet at its tallest point? Okay, well, we draw our tent here. And it says the sides are both 5 feet and the bottom of the house is 6 feet across. What is the height of his dog house in feet? So if this is 6 feet, okay, we're trying to find the height, right? So look what we've done there is we kind of made 2 right triangles. So if this is 5, half of this would be 3. So we're trying to find B right there. So we'd say 3 squared plus B squared equals 5 squared. So we get 9 plus B squared equals 25. 25 minus 9 gets us 16. So we say B squared equals 16. When we take the square root of both sides, we get B equals 4. So the height is 4 feet. All right, we'll skip 14 and 15. Let's go down to the last 3 here. We'll do just number 16 and 17. Says, tell if the following are Pythagorean triples, show your work. So if they are Pythagorean triples, then the biggest number has to be C. So let's say A, B, and C. So for this to work, then 5 squared plus 10 squared has to equal 15 squared. Okay, well, we know 5 squared is 25 and 10 squared is 100. So this is equal to 125. And then 15 squared, when we have that memorized, we would say that is 225. So those are not equal. So we would say, no, that is not a Pythagorean triple. Number 17, 12 squared plus 16 squared has to equal 20 squared. Well, 12 squared is 144, 16 squared is 256, and 20 squared is 400. So when I add 144 plus 256, we do in fact get 400. So right here, since this is true, we would say yes. All right, so that's a little bit about the Pythagorean theorem. There's one other thing that we have to deal with in regards to the Pythagorean theorem, and that involves three-dimensional shapes. Okay, so we'll look at number 1 and 1, 2, and 3 here. So if we notice here, we're talking about a diagonal now. So it says find the diagonal length of each solid figure. So what we notice here, on number 1, we have a box. And we'll have a couple questions like this where it says, you know, so-and-so is trying to ship a baseball bat or a flagpole or something in this box. Will it fit, okay? And so essentially, we're trying to figure out the length of this diagonal right here, okay? There's a formula we can use for that. We just say the diagonal squared is equal to the length squared plus the width squared plus the height squared, okay? That will work, but why does that work? Well, if we look here, we have, let's say we have this 8 millimeter side length and we have our diagonal, okay? Then we could also have, well, let me back that up. Let's say we have our 8 millimeter side length, we have our 6 millimeter width, and really there is a hypotenuse that is on the bottom, the base, if you will, of this rectangular prism. So we could find the length of that right there, and that's going to help us to find the length of the diagonal, okay? And really the better way to do that would be to do this diagonal. So now that now we would have a triangle here as well, okay? So I'll kind of highlight that for us. This is, you know, imagine if we put a right triangle inside this box, okay? And so we're trying to find this hypotenuse right here. But to do that, we have to know both side lengths. We know this is 5 millimeters, but we don't know this part of the triangle, okay? So what we're gonna do is we're gonna use the length and the width to find the length of this part of the triangle. So on the triangle that's like inserted into the box, this is a leg of the triangle. But if I look at the base of my shape, this part right here would act as the hypotenuse of this triangle right here, okay? And I know this is 8, and I know this is 6 millimeters. So I can find this side length. I would say 6 squared plus 8 squared equals c squared, and that's 36 plus 64 equals c squared. Well, that's equal to 100, so when I take the square root, then that tells me that this part right here is actually 10 millimeters. So now I know that this part's 5, this part's 10, and now I can find the hypotenuse up there. So I would say 5 squared plus 10 squared equals the diagonal that I'm trying to find. So now that's 25 plus 100 equals the diagonal squared. So that's 125 equals the diagonal squared, and I take the square root of both sides, and I get the square root of 125 as approximately 11.2 millimeters. So the diagonal is 11.2 millimeters. Okay, so that's kind of how that works. So we'll go ahead and go over to number 3, and we'll use our formula here. So we would say that the diagonal squared is equal to the length squared, so let's say 4 squared, plus the width squared, which is 3 squared, plus the height squared, which is 12 squared. Well, this is 16 plus 9 plus 144. So we get 16 plus 9 plus 144 gives us 169. So now we have d squared equals 169. Take the square root of both sides, and the diagonal is equal to 13 yards, okay? Now that, if I wanted to look at it this way, notice down here would be a right triangle, okay? And if you notice, this would be a Pythagorean triple, 3, 4, 5, Pythagorean triple. So now we have the diagonal, the leg we just found, and 12 as another right triangle. So now we have a 5, 12, 13 Pythagorean triple as well. So those two right there, you can use this formula, just square the length, the width, and the height, add them together, and that's equal to the diagonal squared. Or you can use the Pythagorean theorem essentially twice to come up with the diagonal. Both ways are good. All right, we'll look at number 4, and then we'll be done here. Okay, so number 4, we're trying to find the length of the diagonal. Well, if I notice, I can make a triangle, a right triangle like this. And then I have the height here. Okay, but the problem is they only give me the radius. Well, the radius is 5, which means that the entire thing down here would be 10. So now I have 10 squared plus 24 squared equals c squared. So I get 100 plus 24 squared is 576 equals c squared. So I add those together at 676 equals c squared. And then I can take the square root of both sides, and I get the square root of 676 comes out to 26. So my diagonal here, the diagonal is equal to 26 inches. All right, so with the Pythagorean theorem, we're just trying to find the missing side length, a, b, or c. And remember, a squared plus b squared equals c squared. And then when they throw you a diagonal problem, that'll be a 3-dimensional shape. The diagonal squared is equal to the length squared plus the width squared plus the height squared. Pythagorean theorem.